Welcome back everyone, Tom here, RC Plane Lab. In this video, I'm going to show you how to use the Aero Broach while installing a thick pin style hinge. So let's get started. So here we've got our hinge. This happens to be a Great Plains pinned hinge. Pretty nice, robust hinge. I like the way these work. They're very smooth, especially when you have them in perfect alignment along your trailing edge of your control surface or your hinge line. They are a little bit thicker than the Dubro pinned hinges, which we demonstrated in another video. But I'm going to use my favorite tool for installing flat style hinges, and that is the Aero Broach. Now, when you buy this kit from Aero Broach, it comes with 3 blades, normally, if you buy the package. It comes with a CA hinge blade, which is a little bit thinner than the 60 hinge blade, and then there's a big quarter scale. And that's really the only difference between these 3 is the, try to do that quietly, is the thickness of the blades. There we go. You can kind of see how they differ in thicknesses. So, and the great thing about these is they're marked right on the blade themselves. And there it is. You can see that CA on there. Obviously, that's for a CA hinge. This one is marked quarter, means it's for an old style quarter scale hinge, really thick hinges. And then the one I'm going to use in this demo, the 60 size, which is a little bit thicker than the CA hinge, but it's not quite as thick as the quarter scale hinge. But it's just the right thickness to do this Great Plains pinned hinge. You can see that thickness is about the same. And the thing I really like about this particular tool is that it actually removes material. And if you've watched some of the other hinging videos or watched our podcast episode on hinges, you'll know that I'm a fan of removing material from the hinge pocket as opposed to just taking a blade and separating the fibers. And the reason for that is creating a pocket for the hinge doesn't create that nasty bulge when you slide a hinge in, a slot that might be too narrow, and it creates that bump along your trailing edge or along your hinge line on both the surfaces. Not a fan of that. I like my airplanes to be nice and smooth, so for that I like to use this because it removes that material and gives that hinge a nice pocket to go into. And just like before, I got my leftover dualist stab. I got a couple of places here where I can do some hinging. As always, I've got a nice center line marked on the trailing edge of the stab, and then the control surface I'm going to use in this case, same thing, center line right down the leading edge of the control surface. So this tool is super easy to use. Nice thing is it's kind of sharp, but you can see I'm sticking my fingers. It's not a blade. It does have teeth and they are sharp, but this is much less prone to cutting you than an X-Acto knife. So it's actually a little bit safer to use than an X-Acto also. But like I said, super easy to use. Like I said, got my hinge line drawn. I put a mark there where I want the center line of my hinge. And all you're going to do, I'm going to try to work at a perpendicular, a 90-degree angle to my surface here, to the trailing edge of my stab. And all you're going to do, just like with the Dubro kit that we went over in one of the other videos, I'm going to rock this side to side as I'm plunging it into the wood. Now, I will say, where this tool differs in its technique is that because it comes to a point, it doesn't have 2 points of reference to put on your center line to know that you are at the right orientation to the hinge line. So this one here, you do have to be mindful that you're not going in, at an angle, right? Or rotated, like, in relation to the hinge line. Like I'm not going in at an angle like that. You want to make sure that when you plunge this thing into the wood, that you're actually going 90-degree perpendicular and parallel to the hinge line. Hope that makes sense. But that's one more thing you just have to be wary of, because this thing can rotate on you as you're trying to plunge it in there. But anyway, right on the center line, and then steady downward pressure. And hopefully you can hear that. It's actually shearing the wood as you plunge it into the slot, which is great because we're moving wood out of the way and removing it from the pocket, creating room for our hinge, which again, I like to do because I don't like a bumpy hinge line. And all we're doing, I'll face this towards the camera here. Hopefully we'll be able to zoom in and you'll be able to see the action of this thing. But it's basically just a side-to-side kind of rocking action while I'm providing steady downward pressure. And the depth you go is really up to you. You can go as deep as you want to, but you want to go at least deep enough to make sure that you have the pocket wide enough to accept your hinge. Now, this Great Plains hinge, you'll see that it's tapered. Okay, it doesn't have to be a square slot, which is another great thing about this particular tool is it doesn't create square slots unless you want it to. And I'll show you how to do that when we get to the depth I want to get at here. So again, I'm not going to go all the way. I'm just going to go to that last tooth there. You can kind of see where I've stopped right there. And then what I'm going to do is I'm going to pull that out. And because, like I said, I like to remove material, I've loosened up all those fibers. And now what I'm going to do is I'm going to go back with the back side of my X-Acto number 11 blade, the dull side, okay? And then I'm just going to go in there and remove the rest of that material that the rotor broach or the Aero Broach didn't remove. And you can see that stuff kind of jumping out of that hinge slot when I put this knife in there. There we go. Give that a tap, and you can see the stuff on the board there. And then, just like always, I think the hinge slot is probably deep enough, but the only way to really know for sure is to trial fit that hinge in the slot. And look at there, it looks like I could go a little bit deeper. Repeat the process. Just take my tool and go in just a little bit deeper. I went into the last tooth, so now I know I need to go about another 1/16 of an inch. And I'll look at my tool, about 1/16 of an inch is past the point of the last tooth. So I'll just make sure I get the tool in there that deep. There we go. And I'll pull it out, clear out the slot, just like before. There it goes. See that wood jump out of that slot? And then I'll give it another trial fit. Bingo. There you can see I've got the hinge all the way in there now, right up to the pin where the hinge is pinned. Now, I will say, I'll make a little note here that you'll see here that the hinge, there is a thickness or a depth of the actual pin. Like obviously I can't slide that hinge in any farther because the pin, the joint of the hinge is preventing it from going any further in. Now what that's going to do when I create the slot on my control surface and I do that the same, that's going to create a fairly unsightly hinge gap. And we all know that from some of our other episodes that we were talking about, hinge gaps can lead to flutter, and flutter is a bad thing. So what I like to do on these thicker pin style hinges is I like to bevel that slot with my X-Acto knife just a little bit to make room for that pinned joint of the hinge. And the way I do that is I just take my blade about a 45-degree angle, and I'll just shave off a little sliver of balsa on either side of that hinge center line. I'm going to flip it over here so I can work right-handed. Again, just about a 45-degree angle, and I'm just shaving off a little sliver of balsa on either side of that hinge pocket to allow room for the bulky hinged portion of the hinge. And now when I slide it in there you can see now I've got that hinge about halfway, right up to the center line of the pin. So the pin is sitting right on the trailing edge. If you drew a line, it'd be sitting right on the trailing edge of this, which is going to minimize that hinge gap that I'm looking for when I go to install the other part of the surface, the elevator in this case. So got the hinge cut and the slot cut in my trailing edge of the stab. And the process is exactly the same as before. I'm going to take my hinge, kind of rotate it up a little bit here, and then I'm going to mark it, right? Mark the outer limits of it here. And then it's the same process for cutting the slot in this in the control surface, the elevator in this case. Now the only difference is this is not a built-up structure. Like on my stab here, this is a built-up structure, so there's nothing behind my trailing edge stock, right? Now you'll notice, like in some of the other videos, I've added blocks to the trailing edge to give more material for the hinge to glue to, especially when you get into using pinpoint style hinges. You need that extra material because those hinges are so long. But because we have open structure here, I had some place, if I just had decided I wanted to push this tool all the way through, I'd be able to do that, and those shavings and those sheared off portions of balsa would actually have somewhere to go. Because I'm working in a solid surface here, we're not going to have that. Just like with using the Dubro hinge slotting kit, when I shear these fibers off, they're going to want to collect at the bottom of the pocket, and I may have to go a little deep, grab my knife, pull those fibers out, and then finish the rest of the way. So you just have to keep that in mind. If you plunge it all the way through, just like with the Dubro kit, if you push it too far in and you push all those wadded up fibers in the bottom of the slot, it may want to bulge the trailing edge where it gets thin. And we don't want that. We want nice, smooth surfaces. So take your time and do a little bit at a time. So what I'm going to do here, I marked my hinge location. I'm going to set the tool just like on the stab, put it right on the center line, and then with that rocking motion, going to plunge it right into that surface, trying to maintain a perpendicular, line compared to the hinge line. We don't want to put it in at an angle. We want all our hinges to line up nice and straight. So, yep, I'm going to go about halfway, just like that. And because I'm working with a solid surface, I'm going to grab my knife and pull out those fibers to make room for the rest of it. Just like that. And you can see that wood popping out of the hole because we've sheared it off and we've actually created a pocket, which is, in the end, what we want to do because we don't want those bumps on the hinge line on our control surface. So I know that I needed to go past that point on the other side, so I'm going to just go ahead and go the distance on this one. There we go. That's about as deep as I had it before, and I'm just going to pull that out just like that. Grab my knife, remove the remainder of that balsa that I just sheared off inside that pocket, which is really easy to do when you use the backside of your X-Acto knife. You can also use the hook tool that comes with that Dubro hinge slotting kit if you happen to have one. That's a great little tool for that. Works perfect. There we go. And then because I know I need to make room for that pinned portion of the hinge, I'm going to go ahead and do just like I did on the trailing edge of my stab. Take that and shave off about a 45-degree little sliver of balsa on either side of that hinge pocket to make room for that hinge pin. Go, just like that. Give that a tap, and then I'll trowel fit it. Same thing as with the flat nylon hinges that have the molded in flex point. I will flex this hinge so I'm not trying to push the hinge farther into the pocket. We'll give that a flip, slide that in there, make sure it goes all the way, and presto, just like that. Nice pinned hinge right there. Hopefully you can see that. Rotates nice. I got all my travel and a very, very minimal hinge gap. You can kind of see the gap right there. There you go. And so that's how you prepare the slot for a pin style flat hinge. Just like a flat style nylon hinge, don't install these with CA. Install them with epoxy. Do yourself a favor. And then one extra step that you have to take with these pinned hinges, especially if you're going to use epoxy, which you should, we want to protect this action, this hinging action. We don't want epoxy from the gluing, from the assembling process. We don't want epoxy to get into that pinned area of the hinge, otherwise fouling that nice smooth action. So here's a little trick I learned a while back. You see this trick all over the internet. What I've got over here to the side, I've got my covering iron flipped upside down, a metal lid full of nothing more than Vaseline. And what I'm going to do, dunk it in that liquid. And then, forgot to get my paper towel ready. There we go. And then kind of wipe off the excess. And then I flip it over and do the exact same thing on the other side. Give it a dunk. And the nice thing about that nice shallow lid is it doesn't allow that petroleum jelly, or the Vaseline in this case, to go up onto my gluing surface. And because it was liquid, it's saturated, ran into that hinge joint, so there's no way epoxy is going to get in there and foul up my nice pinned hinge. So next up would be to, just like with our flat style hinges, mix up a little bit of Ron's special epoxy here. Bear with me. I'll try not to cuss as I handle these nasty bottles of epoxy. I'm surprised the peanut gallery didn't like yell at me right there.
Not worth it.
And there it was. All right. Again, I'm just going to use 5-minute epoxy here because I'm only dealing with one hinge. Now, if you're using, if you're doing a complete, a complete control surface, elevator in this case, or a rudder or ailerons, you're obviously going to be dealing with more than one hinge. Do yourself a favor, use 30-minute epoxy. Gives you plenty of time to get everything in there and get everything aligned. And that was something I wanted to mention. With pinned hinges, alignment is very important. Before I glue this hinge in here, I want to mention that when you go to put your hinges in, obviously you're going to mark where you want them on your control surface, the elevator in this case. I'm going to move this out of the way. Once you have created, what I do is I create all the pockets in the elevator, or the horizontal stab in this case, do those first. And then I'll take my elevator and I'll line it up with hinges in the pockets, right? Line it up, and then I'll mark every location where there's a hinge. And on a pin style hinge, I actually make the pockets a little bit wider than the hinge. And the reason I do that is for alignment. Obviously, you want all those pins and all those hinges to be perfectly aligned with your hinge line that runs along the length of your control surface. If they're not, if you have one that's out of alignment for any reason, if it's either rotated or it's stuck in at an angle, that pin in the hinge doesn't line up with your hinge line, it's going to cause binding. And potentially other issues also. Over time, it can cause fatigue of the plastic parts of the hinge, which is bad. You don't want a hinge failing, especially in flight. But if everything is in alignment, you'll have a nice smooth action, and your servo won't have to work so hard to move that control surface. So what I do, again, I get all my hinges set in my trailing edge of the horizontal stab in this case, or whatever control surface I'm working on, and then I'll lay my control surface up next to it when I have all the hinges done, mark those locations on my control surface, elevator in this case, and then I cut the pockets for that. And then, because I've made the pockets slightly wider, when I put the hinge in there, or I put the control surface on there with all the hinges, and I flex it a couple of times, those hinges will want to self-align by the action of moving that control surface. So if there's any kind of misalignment, I have some wiggle room in those slots because I made them a little bit wider for that hinge to sort of find its center, if you will, while I'm rotating that. And then once you've got that done, then you pull everything out, mix up some 30-minute epoxy, and then do what I'm getting ready to do here. It took me a long time to explain that, and I apologize, but that's an important thing to consider, especially when you're using pin style hinges. They need to be in alignment. The flat style hinges are a little bit easier to work with than the Robart point style hinges, but I'm a huge fan of those Robart hinges, and we'll cover that in another video, and I'll explain why I like those. But those are even a little bit more tricky to get in perfect alignment, and even more so because you can install them at different angles to do different things, which is a pretty cool feature of that particular hinge, which I'll talk about when we get to that point. So I think my epoxy is about ready. I made the mistake of setting it up right, so I apologize. But I think I can squeeze some out of here. Yeah, there we go. A little bit of epoxy there. There we go. Sit you over there. And a little bit of part B. equal parts, A and B. Most epoxies, that's how they're mixed these days. You can find epoxies that are mixed 3-to-1 or whatever, but do yourself a favor. Get the stuff that's just equal parts A to B, and you'll be a lot happier. Now, I just used equal sized, just eyeballed it. You can use a scale, especially if you're going to mix up a larger amount. I would recommend using a scale, but it's equal parts A to B by volume, or I think weight also. I've used scale on some of my fiberglassing projects, but for this kind of thing, I just eyeball it. But just like the flat hinge, I start with one side, and I'll try to do that up here so you can kind of see the process. I just give that a smear on one side, and I try to make sure I get it in those holes, and then I flip it over, do the same thing. It's kind of a mess doing it this far away from me, but you can see I've got epoxy on both sides, and it doesn't take a huge amount of epoxy to glue up a hinge. As long as you've got epoxy in those holes, they will find that balsa and give you a good solid joint. And then there we go, just like that. I'm gonna slide that in there. And then once I've got that in, all of them, right? Then I'll do the same thing on the other side, a small thin layer on this side, make sure I get it in the holes, flip it over, put some here, grab some from that slot there since I know my pin is protected because I put some Vaseline on it. There we go. And then I take my control surface, slide that on there, just like that. And then what I do is I normally, on an entire surface, I'll take a piece of masking tape. Once I've done my whole left and right kind of wiggle to get everything in alignment, I take a piece of masking tape on the front side or on the top side, and then again on the back side to hold everything square while that epoxy cures. And then when the epoxy is cured, peel the tape off, give it a crack. You'll usually hear it crack because of the epoxy that is not stuck to the petroleum jelly. You'll hear that break loose, and then you'll have a nice freely moving hinged control surface with a minimal, I said minimal, I've got a small gap, but a minimal hinge gap. So there you go. That's how I install a Great Plains pinned hinge with the cool Aero Broach hinge slotting tool. You can use this tool, like I said, it comes with 3 different blades, so you can use it on the CA type hinges, you can use it on the flat nylon hinges, you can use it on these hinges, any flat style hinge you can use this tool, and it is really my tool of choice when it comes to putting flat style hinges on an airplane. I even sometimes clean up the slots on ARFs with this very tool, because sometimes they don't come straight, so you can straighten them up with this tool. Hope you've learned something. Hope it was fun to watch. Hope I wasn't too boring. Be sure to check out our other videos, and hey, thanks for watching. We'll see you next time.